from Potomac Highlands Regional Jail, and I'm going to talk to you about statistics. Statistics are used to collect and analyze data. Once we've collected that data, very often we use graphs as a way to show the data that we've collected and analyzed. We're going to start with a brief review of our measures of central tendency. That includes our mean, median, mode, and range. Starting with the mean, we find the sum of our values and divide by the number of items in a data set. So if we take a look at an example, what is the average number of wins that the WVU football has had in the past 10 years? So here we have all the records over the past 10 years for the football team, and we'll find that the first number is the number of wins they've had each season. So we're going to add up all of those numbers, and we're going to get a total of 88. But then we need to divide the 88 by 10, which is the number of seasons or the number in our data set. So when we divide 88 by 10, we get 8.8 wins on average per season. If we want to look at the median of a data set, what we do is order our data from smallest to largest values, and then we use a cancellation method to find our middle number. If we have an even number of values, then we take the two middle numbers, add them, and divide by 2. So if we take a look at this example, again, this is our football record here. 4 wins is the least amount of wins they've had in the past 10 years. 11 is the most amount of wins they've had in the last 10 years. So we're going to cancel out. And once we get to the middle, we find that we have 2 values. Again, typically you would add and divide by 2, but because they're both the value of 9, we know that that is our median. Let's talk about the mode. The mode is the number that reoccurs the most in a data set. So if we look at the WVU wins, we will find that they had 3 seasons of 9 wins, but they also had 3 seasons with 11 wins. This means that we have 2 modes. So our modes for this data set will be 9 and 11. Finally, let's talk about the range. The range is where you subtract the lowest value from the highest value. So we're going to subtract 11 minus 4. 11 being the most wins, 4 being the minimum amount of wins. 11 minus 4 is 7, so that is our range. Let's take a look at a few problems that deal with our measures of central tendency. In this example, we are going to find a missing value when the mean is provided. A track coach records the time of his athletes in a 4x400 relay race. He accidentally missed the split of one of his athletes, but he knows their mean time is 64 seconds. If we look at this chart here, we can see the split for each of the athletes. Ashley is the split that we are missing, so we're going to represent her time by X. The mean is also listed at 64 seconds. We're going to set this problem up just like we would set up any other problem when we're finding an average. So we're going to add 66 plus X plus 62 plus 60. And we're going to divide that by the number of data points in our set, which is 4. We know that our mean is going to equal 64 seconds. So the next step here is to add up our values. This is going to add up to 188, and we're going to keep our X, divide by 4, and drop the 64 down. At this point, we're solving for an unknown value, so there is a little bit of algebraic equation solving taking place. This is now a two-step problem. So we're going to multiply both sides by 4, and we're going to cancel out. If we drop this down, 64 times 4 is 256. And now we're at a one-step algebraic equation. We subtract 188 on both sides. This will cancel out. And we are left with x equals 68 seconds. We now know that Ashley split was 68 seconds. That's how we find a missing value. In our next example, we're going to find a weighted average. There are times when some of our data points have higher values than others. A common example is in academic grading. There are some courses that you may take that have a higher impact on your GPA than others. We know that a 4-credit class in college has more weight on your GPA than a 2-credit class would. So here's the example. We take a look at Remy's schedule and her grades. She's taking 5 classes, each varying in the amount of credit hours. And then we have a list of the grades. We can see here how much each grade is worth. So an A is valued at 4 points, a B is worth 3, a C is worth 2 points, and a D would give you 1 point. When we look up here at her scores, what we're going to do is replace B with the number of valued points. So a 4-credit class times 3 points would give us 12 scaled points. If we do this for each class, we can then get the total number of scaled points. So we're going to add 12 plus 8 plus 4 plus 8 plus 9. Now, we're going to then divide that by the number of data points, but not the number of classes, which is 5. We need to look at the number of credit hours, which is 14. When we add this up, 12 plus 8 plus 4 plus 8 plus 9, we're going to get 41. And then we're going to divide that by 14. Our total answer is going to be a 2.9 GPA. If this was not a weighted average, we could probably expect that Remy's GPA would be slightly higher than with the scaled points and the weighted averages. The next piece I want to talk to you about is called standard deviation. This shows how much variation there is from the mean of the data. So a low standard deviation means that our data values are close together and there's less variety in the collected values. So if you look at this bell curve right here, you will see that it's pinched nice and close together. Okay? This is a low standard deviation. Whereas a high standard deviation means that our data is more spread apart. There's more variety in the data that we're provided with. Therefore, you can see the data is spread apart more on that bell curve. So if we again analyze WVU football, we're going to take a look at the weights of our players. We found that there are 107 players on the roster. The lowest weight on the team is 167 pounds. The highest weight is 325 pounds. So there's a good variety between the difference in their weights. If we do our calculations that we just discussed, our measures of central tendency, we'll find that our mean is 228.9 pounds. The median is 218 pounds. The mode is 175 pounds, and we have a range of 158. Our standard deviation is 44.95, and that's a pretty high standard deviation when we're talking about weight in pounds. If you're wondering how we got the standard deviation, I'm going to ask that you hold off on that and watch another video that shows how to solve for standard deviation. There is an entire process and equation that you would use to find that answer. Okay, now if we were to compare the weights of the entire football team to the weights of just the wide receivers for WVU, we're going to get some different answers. There's only 14 wide receivers. The minimum weight is 167, and the maximum weight is 212. Notice how this changes our mean, median, mode, and range. Okay, our answers are a lot closer together. Therefore, our standard deviation is 13.69. That means we have a low standard deviation. The variety of the weights is a lot closer together than when we looked at the entire football team as a whole. So now, let's just take a look at what this would look like on a bell curve. To do this, we're going to start with the mean or the average weight of the entire football team. That number was 228.9 pounds. Okay? And the next thing we do is we talk about, well, what's the weight's one standard deviation from the mean? To do that, you're going to subtract 44.95 from the mean. So when you subtract that, you're going to get 183.95. And we're also then going to add 44.95 to the mean on this side. That will give us 273.85. What this means is that 66%, over half of our players' weight range should fall within this standard deviation, within one deviation from the mean. If we go another standard deviation away, that would be 2 standard deviations. So again, we're going to subtract another 44.95, and we'll get 139. And we're going to add another 44.95, which will give us 318.8 pounds. So if I were to draw this curve, it should look something like this. Okay? And again, this is our mean. This is one standard deviation away. So this is 33% of our players, and this is 33% of our players. They should fall into those categories. From here, we're 2 standard deviations away. So again, this is now going to be, as a whole, 99% of our data. Okay? So what we'll see is that if a value lies more than 2 standard deviations from the mean, we may consider that an outlier. So what's an outlier? It's a data point that is distinctly separated from the other data points in a set. If we look at the WVU football team, there is one player who weighed 325 pounds. They would be considered an outlier because if we go back, 325 pounds lies more than 2 deviations from the mean. That would make them an outlier. Okay? And just on a quick note, what does it mean to be an outlier? Well, if we don't remove those outliers from our data, it could skew the data and we may misinterpret it. So outliers have a very big effect on the mean, range, and standard deviation. Just to show you an example, if these were the prices of homes in a neighborhood, this home right here is going to skew the average cost of homes on that neighborhood block. It's going to make the homes look like they're worth more value than what they actually are. So with the outlier included, okay, what we would find is that the mean price of homes on that neighborhood is $252,000. If you look, the rest of the homes don't even come close to being at that value. So this number really bumped up what it would appear is the value of the homes in that neighborhood, okay? So if we eliminate this number, okay, because it skews our data, and now we collect all this information again, we find that the mean this time is $190,500, which is a much better representation of the homes selling in that neighborhood. Okay. Also notice how the range is a lot less, which also then affects our standard deviation, making that a lot closer together. Okay. Outliers do not have nearly as much effect on the median, because if you remember with the median, we're going to cancel out our biggest values. So that's going to eliminate the 500,000, and that's going to give us a reasonable answer. If we remove the outlier, you can see that there is a slight difference in our medians, but it's not as great of a difference as they were when we looked at these measures of central tendency. So as I mentioned a minute ago, okay, in many cases it's appropriate to remove the outliers from the data set. This gives us a more normalized value of data. Extreme values cause our data to be skewed. So just to understand what skew really means, okay, if more data lies below the mean, okay, then your data is skewed to the right. So here's our example of our West Virginia football players. 228 pounds, so somewhere right around here, was the mean average of weight for the football players. So if you look, if we were to draw this, roughly speaking, the majority of our data is on the left side. That means our data is skewed to the right. So the way to remember it is if your data is on the left, you're skewed to the right. Let's take a look at the next example, if your data appears to be on the right side of the median, then you're skewed to the left. Again, if we look, the majority of our data falls on this right side, so we are skewed to the left. This right here represents a symmetric bell curve. It means that we're balanced on both sides of the mean. So this is our mean average. And here you can see that if I draw this, it's pretty much even on both sides. Therefore, there's really no skew or a very minimal amount of skew. Thanks for tuning in and watching. I hope I was able to give you a little bit better idea of the measures of central tendency, and you have a better understanding of the standard deviation, outliers, and what it means to have skewed data. If you have any more questions, please feel free to always contact us. Thank you very much.